All right, hey guys. So in this video, we're going to be talking about expanding and condensing log functions. So by now you should have an introduction as to how logs work and how to solve for them and sort of what they mean when you're looking at a given equation. So the first rule when we're talking about expanding and condensing these would be your coefficient/exponent rule. So that's looking at, as you can see here, there's a coefficient to your log, and then up here is where you have your exponent. Those don't equal each other. That's just an example, and I'm going to show you how this rule comes into play with logs. So this is really used when we're looking at often with variables in our logs, and it's just another way to look at them either expanded or condensed. So in this form, we know that this can expand out, and I'm going to look at this too. This log base 2, it doesn't matter what the base is because as long as your answer has that same base, so I'll start off with just the base of log 2, I'm able to look at this exponent on this value that the log is going to. And I know that since it's to the power of 2, that's actually going to be my coefficient of x. So it's 2 log base 2x. So you're taking this exponent that's attached to the x squared here, and basically just putting it in front. Now, if you were to plug in a value for x, say x equals 3, go ahead and plug both of these into your calculator, and you should get the same answer. Now, this is how you would condense a certain log like that. So if I'm looking at this, rather than changing your exponent and putting it as a coefficient, you already have that coefficient. So I'm going to sort of do reverse of what I did on the last one. And I know I'm going to keep the log base 2 the same because that does not change with these rules of logs. And I'm going to keep my x. But since there's a coefficient of 3, I know that this 3 actually is affecting this x value, and that will be x cubed. So we'll take a look at some more examples. Right here you have your coefficient 5. So with log base 7, I'm going to keep the 7 the same right there. I'm going to keep my x, and this 5, since it's the coefficient, is becoming the exponent of this x. So I have log base 7 x to the 5th. Now this is like the first example we did. It's sort of backwards of the other one because they are opposites of each other. So if I'm right here, I see this exponent of 3. And now I'm going to keep my log base 7 the same because that remains constant. And I'm going to keep my x. But since this x is to the 3rd power, I can go ahead and know that that will actually be my coefficient. So there's just a short introduction. We'll take a look at more practice problems as we go through this video. The next type of rule to know about log functions is the division and multiplication rule. This one's a little more complex just because it's weird to look at. So if I'm looking at this, I see log base 2x minus log base 2y. And without any x or y values, you can actually simplify this. So when I see this subtraction, when it comes to logs, that actually means division. And you want to make sure that when you're looking at it, that your log bases are the same. So since they're both log base 2, I know I can condense this. Say it were log base 3 and log base 2, then I could not combine these because they're different log values. So with that being said, since they're both 2, I can carry down this log base 2. And because of this subtraction, you can actually divide the x and y. So you'd have x over y. So it's basically condensing this into one. You're taking your log base 2x, log base 2y, taking the log base 2, putting them together, and knowing that since you're subtracting these two logs, you're actually going to be dividing what these logs are of, so x over y. Taking a look at this one, there is no number attached to the log, but as we know, log base nothing is essentially log 10. So if I'm looking at this, I want to combine it, and this is supposed to be higher up, so let's pretend like that's not the base of the log. So since I'm adding them together, it's opposite of what we did above. So because this is subtraction, meaning division here, when it's addition, it's going to be multiplication. So I have log xy. So just a little rule to remember, if logs are being subtracted, you can divide them as long as they have the same base. That's important to note, that they must have the same base. And then if I'm adding two logs that have the same base, that is multiplication. So you can go ahead and check this for yourself if you plug in x equals 2 and y equals 3 and do the original log expression and then the condensed log expression, and you should get the same value. All right, so now on your website, there should be a link to some practice problems, so we're going to work through these. This one here, we're going to condense this. So if I'm looking at this homework practice problem, this is number 1 on your sheet. I'll take a look and I can start with each one. So if I'm starting with just this first part of it, I do see that there's subtraction, so I know in the future I'll be dividing what these log bases are of. But looking at just this, I'm going to carry down the log base 9 because I know that stays the same. And then I have 2. And since this 3 is the coefficient of this log, that actually becomes the exponent of what the log is of. So that means it's 2 cubed. And I'm going to switch the color just so it's easier to see. Right here, I'm going to condense this. So again, I carry down the log base 9, and then I have my 5. And what we learned before, this 2, since it's the coefficient, it becomes the exponent for what that log is of. So then I have this right here. Now that I see this, I know that I'm subtracting these from each other. So again, since they're both log base 9, I can carry down the log base 9. And then I have 2 to the power of 3, so that's 8. And then I have 5 squared over here, and that's 25. So I'm just taking a look at what these values would be. And because of this subtraction, I know that whatever I'm taking the log of is what I'm going to be dividing by. All right, practice problem 2. You can go ahead and try working through this on your own, or you can follow along with me. So this here, it looks like this one is already good. This one's good. But then here I see this coefficient of 6, and I know that since it's the coefficient, I can make that the exponent of what we're taking the log of. So if I go down here, I'll write log base 6, and then z to the 6th. And then I'm going back up here, I see these plus signs, and with logs, since they're all log base 6, I know that I can combine them. So they're all going to be log 6. And then since this is addition and it's logs, I know that I can multiply each of what these log base go to. So I will have x, y, and don't forget that you condensed this earlier, so you have z6. All right, last practice problem of this video is number 3, so you can follow along on your worksheet. We're going to start with just this section of it. So I see that there's a coefficient of 2, and because of the coefficient and exponent rule, I know that I'm going to take this log base 5, then I have my x still, but this coefficient goes to the exponent of what I'm taking the log of, so I have x squared. Then I'm going to do the next part of it. It's 12 log base 5y. So, like I said, you take your coefficient and you know that that becomes the exponent for whatever you're taking the log of. So I have log base 5y to the 12th. All right, so now I'm going to go and condense this further because there is that addition in the initial problem. So again, addition, since I do have both log base 5 and log base 5 here, I know that I can combine these together or condense them, like I said before. And since it's addition, I know that I'm multiplying this x squared and the y to the 12th. So I'm overall taking log base 5 x squared times y to the 12th.